Hi guys, welcome to another one of my lectures, RT Dawlat. And today I want to be looking at the CSEC syllabus, and I want to be looking more specifically at measuring length. Now this is a section A objective, and it is normally done at the Form 4 level or at the beginning of the syllabus, and it examines the use of three instruments: a ruler, a vernier caliper, and a micrometer screw gauge. So when we talk about length, we're going to talk about a ruler. Then we're going to look in depth at how a vernier caliper, and of course a micrometer screw gauge. So the first thing is, all three are used to measure length, and it just depends on the size of your measurement that makes each one more applicable, more accurate. So if we have a ruler, you normally place your ruler parallel to whatever body you are measuring the length of, and your ruler gives you a centimeter value. So let's say I'm going from 0 to 1. I'm just kind of extrapolating a 1 centimeter from my ruler, and you will notice, guys, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So all of these markings here correspond to millimeter values. So I have 10 millimeters that make up 1 centimeter. So it means that the smallest unit is 1 millimeter. So the smallest division on my ruler is 1 millimeter, or 0.1 of a centimeter. So if I have the length of a book, I want to get the length of a table, these are things I could use a ruler and then extrapolate it to a meter rule, again depending on the size of my body. Now let's say I want to get the diameter of a beaker, for example, or maybe a test tube. I will use a more precise value, a more precise instrument called a vernier caliper. Now, the main difference between a vernier caliper and a ruler is that it gives you a smaller degree of precision, which means that it gives you a smaller division. So if the smallest unit of a ruler is 1 millimeter, then all of your measurements on a ruler will be up to 1 decimal place according to the centimeter scale. So you will get 2.1, 4.5, 3.6, right? But if we want it now for a smaller dimension, right? We want it to get up to 2 decimal places, right? So that's the first difference. It's a measurement up to 2 decimal places on the centimeter scale, okay? And it consists of 2 scales. You have a main scale and you have a vernier scale. Now, the vernier caliper, right? I'm just going to look, I'm not getting into the specifics of how it is used in terms of how you, displace the jaws and you lock in the measurement. I'm talking about how to read it, okay? So here, we're going to first draw our main scale. Now, the main scale is like your ruler, and we'll consider it in centimeters. There are some vernier that give you values, in millimeters, but we consider for this one centimeters, right? The main scale. So we're going to start with 0, and again, this is just like our normal ruler. So let's say I'm going up to 1. So I'm just again expanding, right? So you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So sorry if they're not equal. I'm doing this freehandedly, right? So I'm just enlarging it for you to see. So these are again from 0 to 1 centimeter. So all of these are millimeter values. That's your main scale. Now I am going to show you where our vernier scale lies. So let's say our vernier scale, after I have locked in centimeters, right? At the bottom of your main scale is a sliding scale called your vernier scale, right? That is the scale in green. And what the vernier scale is composed of is if I take 1 millimeter and I divide it now into 10 divisions. So I am taking my smallest division, which is 1 millimeter, and I'm dividing it now into 10 smaller divisions. So the smallest division in the vernier scale, that is each marking here in the vernier scale, corresponds to 0.1 millimeter. 1 millimeter divided by 10 is 0.1, and that corresponds to 0.01 centimeter, which is how I started up here by saying that my vernier caliper gives me 2 decimal places on the centimeter scale. So it means my smallest value is 0.01. Okay? Now, how to read it? So the first thing we're going to do is we're going to see where the 0 marking lies, right? So your 0 marking lies between 3 and 4 on the main scale. So you take the value immediately to the left. So the main scale value works out to be 3 millimeters or 0.03 centimeters. Then I'm going to add it to my vernier value. Now you are going to examine where the vernier scale, right, which marking on the vernier scale aligns vertically with the marking on the main scale. And what I did was that I kind of highlighted in blue that this was the 7th marking. So the 7th marking on my vernier scale would correspond now to, remember these are, so each one will be like 0.1 millimeter, 0.2, 0.3. So if it's a 7 marking, it would correspond to 0.7 millimeters. So it will be 0.7 millimeters or 0.07 centimeters. So now to get the total measurement, I add the 2. So I get 0.37 centimeter. And if you think about it logically, if the 0 lies between 3 and 4, I do not know what is the specific placing that it may. I might just eyeball it and say, okay, it looks like maybe 3.5 millimeters, right? So what the vernier does is that it gives you a smaller degree of division that corresponds to a more accurate value. All right, let's move on to the next instrument, which is called your micrometer screw gauge. Now this one has an even smaller degree of precision, where it gives you up to 3 decimal places in the centimeter scale. That means you have 2 decimal places in the millimeter scale. So what it does, just like how the vernier here took 1 millimeter and divided it into 10 divisions to get that 2 decimal places in the millimeter scale, that is your smallest division corresponds to 0.01 millimeters. We took 0.5 millimeters and we divided it now into 50 divisions. Right? So if I did that, 0.5 divided by 50 would give me 0.01 millimeter. So again, you would have, in terms of how to read it, you would have your main scale, but your main scale in your micrometer screw gauge is in millimeters. And this is different to your vernier caliper, right? So again, you would have now, right, a different scenario here. Right. So you have 0.5, 1 millimeter, 1.5, 2 millimeter, 2.5, 3 millimeter, 3.5, 4 millimeters. So what we are doing now is that we are going to take this 0.5 millimeter and we're going to divide it into 50 divisions, right? And that is where, when you look at your rotating scale, I'll show you in perspective just now, your rotating scale would give you 0.5 millimeters over 50, which would be 0.01 millimeters, right? So, right, so let's do it in perspective. So normally what you would have is your main scale, and then you would have it being parallel to your rotating scale. So your rotating scale would go from 0 to 50, right? So you would have 0, 50, depending on how it's rotated. And each value here, you'll see like 35, 40, 45, etc. will actually be 0.35 millimeters. So remember, because you are going up to 50, you would have values like 10, 11, 12, up to 50, right? But they would correspond to 0.35 millimeters. So now, because our main scale values has smaller subdivisions, right? So let's go. So this is millimeter main scale, right? So you have 1, 1.5 here, 2, 2.5, 3, 3.5, 4, 4.5, right? So here I'm going to see where your rotatable scale, rotating scale, basically will slide along the main scale. So what you will do is that, again, you are going to look at the value that precedes. You are going to look at the millimeter value on the main scale that comes just before the rotating scale on the immediate left. And that corresponds here to 4.5 millimeters. So my main scale value is 4.5 millimeters. Now your rotating scale, just like how your vernier scale, you're looking for an alignment between your vernier and your main. The same principle applies here, where you're looking for a horizontal alignment between your rotating scale and the main scale. So here, this horizontal alignment corresponds to a value of 35, but you cannot put 35 because remember that is 0.35. So your rotating scale will be 0.35 millimeter. So when I add it up, I get 4.85 millimeter. And typically, your micrometer screw gauge is used most popularly to get the diameter of a grain of hair.